In previous video, we learned about the important concepts of a discrete probability distribution. In this video, we'll learn about one of the varieties of a discrete probability distributions, binomial probability distribution. Binomial distribution allows us to deal with situations involving two categories of outcomes. For example, left, right, boy, girl, tails, heads, front, back of the playing card. We'll learn about the requirements of a binomial probability distribution and how to use StatCrunch and TI graphing calculator to calculate the important parameters of a binomial probability distribution: mean, variance, and standard deviation. A binomial probability distribution results from a procedure that meets the following four requirements. The procedure has a fixed number of trials. The trials must be independent, meaning that the outcome of any individual trial does not affect the probability in the other trials. However, when sampling without replacement and the sample size is no more than 5% of the size of the population, then we treat selections as being independent, even though they're actually dependent. Each trial must have all outcomes classified into two categories, commonly referred to as success and failure. It's not success and failure as in English language. The success would be considered when we throw a coin and we want to know how many times out of 20 it will land tails up. That would be considered the number of successes. The number of failures would be when the coin lands heads up. And the last requirement, the probability of a success remains the same in all trials. We'll use the following notation for the binomial probability distribution. S and F is success and failure denoted the two possible categories of all outcomes. P of S or P, probability of success. P of F or 1 minus P, the complement of probability of success, is probability of failure, abbreviated as Q. And the total number of trials. X is a specific number of successes in n trials. P, probability of success in one of the n trials. Q, probability of failure in one of the n trials. P of X, probability of getting exactly X successes among n trials. Binomial probability distribution can be calculated in several ways. First, using the binomial probability formula. P of X equal n factorial divided by n minus x factorial times p to the power of x times q to the power of n minus x, where n is the total number of trials, x is the number of successes among n trials, p is the probability of success in any one trial, q is probability of failure in any one trial, found by subtracting p from 1. Binomial probability distribution can be also found by using table A1. We will look at how to find binomial probability distribution using StatCrunch and TI graphing calculator, because technology makes it so much easier to find the binomial probability distribution, and you will see it on the following example. When an adult is randomly selected with replacement, there is a 0.85 or 85% probability that this person knows what Twitter is. Suppose that we want to find the probability that exactly 3 of 5 randomly selected adults know what Twitter is. First, let's identify whether this procedure results in a binomial distribution. Let's check for the requirements. The first requirement, that the procedure needs to have a fixed number of trials. Well, the number of trials is 5 because we asked 5 randomly selected adults. The trials need to be independent. They are independent because it identifies that the procedure is done with replacement. Third, does this procedure has two categories? Yes. The adult whether knows what Twitter is or does not know. So this requirement is also met. The probability of success remains the same in all trials. The next adult that we will ask might also know what Twitter is, so the probability of success just remains the same in all trials, Therefore, all four requirements are met. Therefore, this procedure does result in a binomial distribution. If the procedure does result in a binomial distribution, which we know that it does, identify the values of n, x, p, and q. N is the total number of trials. In this case, it would be 5 randomly selected adults. X is the number of successes. In this case, it would be 3 adults that said they do know what Twitter is. So X equal 3. P, probability of success. Probability that the person knows what Twitter is 0.85. And Q, remember Q is a complement of P. So it equal to 1 minus P. 1 minus 0.85 is 0.15. Now that we identify the values of N, X, P, and Q, we can proceed with the next part. Let's keep in mind that N, total number of trials, is equal 5, and P is equal 0.85. We will need to enter these two numbers in the StatCrunch. Let's look at the part C. Find the probability that when 5 adults are randomly selected, exactly 3 of them know what Twitter is. So we're looking for probability P of the number of successes X equal exactly 3. In the StatCrunch, click Stat, Calculators, Binomial. When this page opens up, change the number N to 5. P is 0.85. Now we need to change the sign to equal 3. The number of successes is exactly 3. Compute, round to 3 significant digits, 0.138. 0.138. Now let's find the probability that when 5 adults are randomly selected, at least 3 of them know what Twitter is. What does at least 3 of them? At least mean 3 or higher. So we're looking for probability of the number of successes being greater or equal 3. Going back to StatCrunch, change the inequality sign to greater or equal 3.973, rounded to 3 decimals. You can also see on the graph the change in the color, what probability counted. Probability that 3 people know what Twitter is, probability that 4 out of 5 know what Twitter is, and probability that 5 out of 5 know what Twitter is, equal 0.973. Now let's find the probability that when 5 adults are randomly selected, less than 3 of them know what Twitter is. So we're looking for probability the number of successes is less than 3, not including 3. 3 is not less than 3. 3 is equal to 3. And we're looking for the probability that less than 3 of them know what Twitter is. So we choose the inequality sign less than. Go back to StatCrunch. Change the inequality sign to less than 3. Probability is equal 0.0266, rounded to 3 significant digits. Now let's calculate the probability that when 5 adults are randomly selected, more than 3 of them know what Twitter is. Let's convert it into mathematical statement. We're looking for probability P of the number of successes X is more than 3. More than 3 will not include 3. It will include 4 and 5. So change the inequality sign to greater than 3. And you can see on the graph that it's highlighted probability of 4 people and probability of 5 people knowing what Twitter is. 3 is not highlighted because 3 is not greater than 3. 3 is equal to 3. So the probability that more than 3 adults know what Twitter is out of 5 is 0.835. And finally, let's find the probability that when 5 adults are randomly selected, at most 3 of them know what Twitter is. Let's translate it into a mathematical statement. At most mean 0 or 1 or 2 or 3, including 3. So the inequality sign would be less or equal 3. Let's enter it in the StatCrunch. Choose the sign less or equal 3 equals 0.165 rounded to 3 significant digits. And finally, let's learn how to find the parameters of the binomial probability distribution, mean, standard deviation, and variance, and how to use them for critical thinking. We know in statistics, it's not about just to find the number, it's also how to use this number and how to make conclusions from the data. Mean is found by multiplying n, the number of trials, times p, probability of success. Variance is found by multiplying n times p times q. Variance is sigma squared. Standard deviation is the square root of sigma squared, and equal to square root of n times p times q. When we make conclusion about the data, we use range rule of thumb to identify significant values, significant high and significant low values. Significant low values are located 2 standard deviations to the left of the mean. Significant high values are located 2 standard deviations to the right of the mean. To find significant low values, we subtract 2 standard deviations from the mean, and to find significant high values, we add 2 standard deviations to the mean. Let's use the same example with n equal 5, p equal 0.85, q 1 minus 0.85, 0.15, to find mean, variance, and standard deviation. Mean is equal n times p equal 5 times 0.85 equal 4.25. Variance is equal n times p times q is 0.6375, and standard deviation is equal square root of n times p times q. Square root of 0.6375 is 0.798 rounded to 3 significant digits. Now, how are we going to use these results to identify significant high and significant low values? To find significant high values, we add 2 standard deviations to the mean. 4.25 plus 2 times 0.798 is equal 5.8. Let's round it. And significant low values located mean minus 2 standard deviations. 4.25 minus 2 times 0.798 equal approximately 2.6. Now, what does that mean? It means that 5.8 would be a significant high number of people who know what Twitter is. But because we only have 5 total number of people, that we don't have significant high values. However, let's look at significant low values. Significant low value will be 2.6. It means that the probability of getting the number of people 2 or 1 or 0 who know what Twitter is significantly low. In the next video, I will show you how to use graphing calculator to calculate binomial probability distribution.